In this session, we are going to solve a few problems based on applications of trigonometry related to heights and distances. Let's take a look at the first question. The angle of elevation of a cloud from a point 100 meters above the lake is 30 degrees. So let us draw the diagram. This is the surface of the lake. This is the surface of the lake. And there is a point which is 100 meters above the lake. So there is a point which is situated 100 meters above the lake. Let this particular point be P. So P is 100 meters above the lake. And the angle of elevation of a cloud from this point P is 30 degrees. So if you stand at the point P, then this is the normal line of sight. This is the normal line of sight. So because there is an angle of elevation, it means that I have to look upwards towards the cloud. And therefore the angle of elevation here is found to be 30 degrees. So this is the cloud. Let us name this cloud as C, as the point C. Now of course I can drop a perpendicular from the cloud to the surface of the lake, and that is going to be perpendicular. Let us name these points as A and B. Let's read on. And the angle of depression of its reflection in the lake. So this particular point C is going to be reflected in the lake somewhere at the point T, right? So D is basically the point where the cloud is reflected. So D is going to be cloud's reflection. And now it is said that the angle of depression of the reflection, that is the angle between the normal line of sight and depressed line of sight, this particular angle is found to be 60 degrees. So this angle is 60 degrees. And therefore I can extend this particular point B till the point D, right? And now I know that the distance between the point C and B, so CB is the height of the cloud. CB is the height of the cloud above the lake. And BD or DB is the depth of the image below the lake. And we know that according to the laws of reflection, the length CB is going to be equal to DB. So now we can consider this particular horizontal distance as x. So let's consider PQ as x. I want to find the height of the cloud above the lake. So let me assign a variable h for CQ. I know that because APQB is a rectangle, I know that this length is also going to be 100 meters, which means that the length CB is going to be 100 plus h, and therefore the length DB is also going to be 100 plus h. The reason for that is because the length CB equals DB. If CB is equal to 100 plus h, because that is the addition of CQ and QB, therefore the distance BD is also going to be 100 plus h. Now of course we want to find the value of h plus 100 because the total height of the cloud above the lake is basically 100 plus h. Therefore, if I find h, I can find 100 plus h. So I will pause for a few seconds while you take a look at the question and the diagram. Let me repeat a few parts again. P is the point above the lake, which is 100 meters above the lake. And C is where the cloud is located. So C is where the cloud is located. D is the point of the reflection of the cloud. The line AB, the line segment AB is basically the surface of the lake. So let me mark the surface of the lake with blue color. The angle of elevation of the cloud from P is 30 degrees, that is marked over here. And the angle of depression of the image is 60 degrees, which is also marked. and now I want to find the height of the cloud above the lake. So let me pause for a few seconds and then I will solve this question. So now that there are two variables in this particular diagram, first I am going to consider triangle CPQ and find the relation between h and x. So I can say in triangle CPQ, I can say tan 30 degrees. So tan 30 is going to be h upon x, the opposite side upon the adjacent side. And therefore 1 by root 3 is equal to h upon x. On cross multiplication, I get x equals h root 3. This is the first relation between x and h. Now I need to frame a second relation. So for that, let me pick the triangle PQD. So I can say in triangle PQD, I can say that tan 60 degrees. So tan 60 is going to be the opposite side. So how much is the opposite side? Opposite side is QD, and QD is going to be 100 plus 100 plus h. So 100 plus 100 plus h, the whole divided by the adjacent side, which is x. Tan 60 is root 3. So root 3x is equal to 200 plus h, and this is the second equation. So now I have two equations to solve. There are two variables. So what I'm going to do is, I'm now going to substitute x as h root 3. That is the first equation, isn't it? Therefore, I will substitute x as h root 3 in the second equation. So it is root 3 times x. So what is x? X is h root 3. That equals 200 plus h. Therefore, 3h is equal to 200 plus h, which means 2h is 200, and this implies h is equal to 100. Therefore, this particular height is 100 meters, and therefore the complete height of the cloud above the surface of the lake is going to be 100 plus 100, that is 200 meters. This is going to be the complete height of the cloud above the surface of the lake. This is how I solve this particular question. Pausing for a minute while you can take a look at the solution. Moving on to the next question. The angle of elevation of a bird from a point 75 meters above the ground or 75 meters above the lake. Consider that instead of ground here, let's assume that there is a lake, or above the surface of the lake. So the angle of elevation of a bird from a point 75 meters above the ground. So this particular point P is 75 meters above the ground. Let Q be the foot of the perpendicular on the ground. is found to be 30 degrees. So angle of elevation of the bird, that means the bird is a bit higher and there is an angle of elevation. So this is going to be the normal line of sight. The horizontal line is the normal line of sight. And this is the angle of elevation which is found to be 30 degrees. This is where the bird is situated. So the reflection of the bird, so this is going to be the distance between the bird and the lake. So this is the point on the lake. Let us again shade the lake in blue color. So this is the lake. This is the surface of the lake, right? And the reflection of the bird in the lake is going to be at B dash. That is at this particular point. B dash is going to be the reflection of the bird. Reflection of the bird in the lake, right? And the angle of depression of this particular reflection is found to be 60 degrees. Is found to be 60 degrees. So this particular angle is going to be 60 degrees. And I know that the distance between the bird and the lake, that is the distance BR, is going to be B dash R. Because again, according to the law of reflection, the distance between the mirror and the object is equal to the distance between the image and the mirror, right? So this is the angle of depression which is found to be 60 degrees. And now I want to find the height of the bird from the surface of the lake. So let's assume that this particular height is marked as H and this particular height is marked as 75. Therefore, the distance B dash R is going to be 75 plus H. Again, the horizontal distance is not known. Please note that if I take any triangle over here, there are two options. One is this triangle. So let us name this particular point. Let this point be C. So if you take triangle BCP, you need the horizontal length. And if you take the triangle B dash CP, in that case also you need this horizontal length. So let us label this horizontal length as X. Again, this is a situation where you have two variables and therefore you need two equations. So I will say in triangle BPC, I can use tan 30. So tan 30 is going to be H upon X, which means 1 over root 3 is H upon X, and therefore I can say that X is equal to root 3 times H. This is the first equation. And again I can frame one more equation, that is by taking the triangle PCB dash. So I can say in triangle B dash PC, tan 60 degree. So tan 60 degree is going to be, if you think about the opposite side, it is 75 plus H, the whole divided by the adjacent side, which is equal to X. Therefore, root 3 is equal to 150 plus H divided by X. On cross multiplication, root 3x is equal to 150 plus H. This is the second equation. Now, I want to find the variable H. So let me substitute the second equation. So let's substitute equation 1 in the second equation. What I mean by that is, let's substitute X as root 3H. So this equation therefore becomes root 3 times X is H root 3. So this is root 3H is equal to 150 plus H. And therefore 3H is equal to 150 plus H, which means 2H is equal to 150. And this implies H is 75. Therefore this length, this H is 75. And therefore the total height of the bird from the lake is going to be 75 plus 75, that equals 150 meters. So the height of the bird from the surface of the lake is found to be 150 meters. You must have noticed a pattern that if the angle of elevation happens to be 30 and the angle of depression of the reflection happens to be 60, then the height is always twice of the height above the surface of the lake. It is twice the height of the point above the surface of the lake. So if the point is at 75 meters, then the cloud or the bird or water object is there in the sky, it is going to be at twice of 75, that is 150 meters. Of course, this is only when you have a lake problem and when the angles of elevation are 30 and 60. So pausing for a minute before taking up the next one. Moving on to the next question. Let's try out this question. Two pillars of equal height stand on either side of a roadway which is 120 meters wide. So let's assume that this is the roadway. So again imagine that the road is passing into the screen right now. The width of this screen or width of this particular roadway is 120 meters. So this particular width is 120 meters. And now it's given that two pillars stand on either side of the roadway. So let's have two pillars of equal height. So their height is equal. They stand on the two sides of the roadway. At a point in the roadway between the pillars, the angle of elevations of the pillars are 60 degree and 30 degree respectively. So at some point over here, at some point P, the angle of elevation of both the pillars, is 60 degree and 30 degree. That means this particular angle is 30 degrees and this angle is 60 degrees. Please note that the more closer I am to a pillar, the more is the angle of elevation, right? So the angle of elevation is 30 and the angle of elevation is 60. We have to find the height of each pillar. So let us assume that height of each pillar is h. We want to find the height of each pillar and also the position of the point. So we basically have to find three things here. So in this problem we have to find, first we have to find the height of the pillar. Then we want to find the distance AP and then the distance BP. So let's see how we can go about this question. Of course, over here, I don't see a variable being assigned for either AP or BP. So let's assign the variable X for AP. So if I assign the variable X for AP, then the length of BP is going to be 120 minus X. So this particular width is therefore going to be 120 minus X. So this is 120 minus X, right? And now what I can do is, I have two variables. I can frame two equations because I have two triangles here. So let me frame the equations which will connect the variables H and X. So let's label the points C and D. So I can say in triangle BPD, tan 30 degree, tan 30 is H upon 120 minus X. Tan 30 is 1 by root 3, which is equal to H upon 120 minus X, which means 120 minus X is equal to H root 3. This is the first equation, right? Now I can frame one more equation which connects H and X. I can take in triangle APC, I can say tan 60 is equal to h upon x, because tan 60 would be the opposite length is h and the adjacent length is x. Therefore, root 3x is equal to h. This is the second equation. So now I have two equations in terms of x and h. I can definitely solve these two equations. So I can substitute h as root 3x in the first equation, because second equation says h is root 3x, so I can substitute that in the first equation. So 120 minus x becomes equal to h is root 3x multiplied by root 3. Therefore, 120 minus x is equal to 3x, and therefore x is equal to 30. So if you solve this equation, you get x equals 30. And if x is equal to 30, I know that h is root 3 times x, that is root 3 times 30. And that is 30 into root 3 is 1.732, which if you find out is going to be 51.96 meters. Therefore, the height of this particular tower, the height of each tower is h, which is 51.96 meters. The point P is x meters away from A. So x in this case happens to be 30. So point P is 30 meters from the point A, and 120 minus 30, that is 90 meters away from the point B. Right? This is the location of this particular point on the ground. The point P is 30 meters away from A and 90 meters away from B. This is how I can solve this particular question. So again, let me pause for a minute, take a look at the word problem, the diagram, and of course the solution. Moving on to the next question. Let us consider the following problem. A man on the top of a vertical observation tower observes a car moving at a uniform speed coming directly towards it. If it takes 12 minutes for the angle of depression to change from 30 degree to 45 degree, how soon after this will he reach the observation tower? Find the answer correct to the nearest second. So there is a vertical observation tower. So this is the ground. This is the vertical observation tower. A man is standing on the top of this tower. So the man stands at point A, and AB is the vertical observation tower. and he notices a car at an angle of depression of 30 degrees. So if he stands at the point A, of course the normal line of sight is parallel to the ground. So this is the normal line of sight. And he observes a car at an angle of depression of 30 degrees. So he observes that the car is located at point C. The angle of depression is 30 degrees. Now it takes 12 minutes for the angle of depression to change from 30 degree to 45 degree. That means the car's angle of depression after 12 minutes is going to be 45 degrees. So this particular angle is therefore 45 degrees. Now we have to find how soon after this will he reach the observation tower. So it takes him 12 minutes. It takes him 12 minutes to go from the point C to the point D. The question that they are asking us is, how much time does it take for this particular person to reach the foot of the tower? This is the question. So let me leave you again with a minute or so to take a look at this particular diagram and understand the problem, and then we will solve the question. Now, of course, let me convert the angle of depression into angle of elevation. These angles are equal because they are alternate interior angles and the lines are parallel. So pausing for a few seconds. So now let us solve this particular question. Please note that there is absolutely no measurement distance wise that is given in this problem. But the idea here is, we know that because the car is moving at uniform speed, as the car moves at uniform speed, I can definitely say that the distance covered by the car is going to be directly proportional to the time that it takes, isn't it? Because if there is more distance, then it will take more time, and if there is less distance, then it takes less time. So if you're counting less time, it means that it will cover less distance. If you count more time, then it will cover more distance. Or the other way to look at it is, if you want to cover more distance, you need more time if you're going at uniform speed, which means the distance covered by the car from point C to point D, that is the distance DC, divided by the time taken. The time taken is 12 minutes. This is going to be equal to the distance between the point D and B is going to be equal to the distance between point D and B divided by whatever time it takes to cover the distance dB, isn't it? Because the distance upon time, so this is the speed of the car between D and C. If you think about it, the speed of the car between D and C is going to be the distance, that's DC, divided by the time is 12 minutes. Similarly, the speed from D to B, speed is given by distance upon time, that is going to be dB upon T, and its uniform speed, that is the speed is same in both cases, because the speed is same in both cases, I know that SDC is equal to SDB, which means that these two ratios should also be equal to each other. And therefore, if I interchange D with TC, that is T goes to multiplication and DC comes down to division, I know that T upon 12 is equal to dB upon dC. This is one main idea that I have reached so far. So what I need to do is somehow I need to find the ratio between dB and dC, these two distances. So let me do one thing. Let me assign some variable. So let dC be x and BD be y, and let the height of the tower be h. Now somehow we need to find a relation between x and y, because I know that over here the length dB essentially is y and the length dC is x. So somehow if I can find the relation between y, I should be able to find the time t. So let us take up the two triangles and let us build a relation between them using trigonometric ratios. So I can say in triangle ABED, I can say that tan 45 is equal to h upon y. Tan 45 is 1, so 1 is equal to h upon y, which means y is equal to h. So this is the first relation that I can build. Similarly, I can take in triangle ABC. So when I say triangle ABC, it basically means this whole triangle. So in this whole triangle, I can now take 30 degree as my angle of reference. So I can say tan 30 is therefore equal to the opposite side, that is h, upon x plus y. And tan 30 is 1 by root 3 and h can be replaced by y. So y upon x plus y. Cross multiplying. So what I've done is I've replaced h with y here because of the first equation. So y plus x is therefore equal to root 3y. I want a relation y upon x. So now I have y plus x is equal to root 3y, which means x is equal to root 3y minus y, and therefore x is equal to root 3 minus 1 times y. Or in other words, 1 by root 3 minus 1 is equal to y upon x. Now because y upon x is 1 by root 3 minus 1, I can say that therefore I can now conclude that t upon 12 is equal to 1 by root 3 minus 1, which means time is equal to 12 divided by root 3 minus 1. I can rationalize the numerator and denominator. So this becomes 12 times root 3 plus 1 divided by 2. 12 and 2 cancel 6 times. So this becomes 6 into root 3 plus 1. And now I can calculate the value of this. This is going to be, so let me calculate this here. This is going to be 6 times 1.732 plus 1, which is 6 times 2.732. Now I can calculate the value of this. This is equal to 16.392 minutes. And this I can be easily converted into seconds. So it is going to be 16 minutes and 0.392. So 0.392 minutes basically will be 0.392 multiplied by 60. That is going to be 24 seconds. So therefore the answer is 16 minutes and 24 seconds. So the time taken by this particular car to reach the base of the observation tower is going to be 16 minutes and 24 seconds. This is the final answer. So again, to quickly recap what we did. A is the point of observation. C is where the car initially was. It took 12 minutes for the car to reach the point D. The question is, how much time does it take further to reach the point B, which is the base of the tower? Now the angle of elevation is 30 degree here. Of course, we converted the depression into elevation. So the angles are 30 and 45. So according to the idea here, because I am traveling at uniform speed, which is given to me in the question. So because I am traveling at uniform speed, the speed between the points D and C is the distance which is dc divided by time is 12, and the speed between D and B is going to be the distance dB upon time t. Because it is uniform speed, both these speeds are equal, which means dc upon 12 is equal to dB upon t. Interchanging dc with t, I get t upon 12 is dB upon dc. Now I have marked dB as y and dc as x. Therefore, this is y by x. So this is the first conclusion that I reach. Now somehow I need to find the value of y upon x. So if I want to find the value of y upon x, I am going to take the first triangle, which is triangle ABD, in which I get h equals y. So this is the second conclusion that I reach. And then I take the triangle ABC. So in the triangle ABC, I get tan 30 is h upon x plus y. So I get y upon x is equal to 1 upon root 3 minus 1. This is the third conclusion that I reach, right? This is the third conclusion. And therefore, because y upon x is 1 by root 3 minus 1, I substitute t upon 12. So from the first and third equation, t upon 12 is going to be equal to 1 by root 3 minus 1. Shift the 12 to the other side and then rationalize the denominator. I get 6 multiplied by 1.732 plus 1, which is 16.392 minutes, and that is 16 whole minutes, and 0.392 minutes can be converted into seconds by multiplying by 60, and therefore the answer is 16 minutes 24 seconds. So this is how I solve this particular question. Pausing for a minute while you take a look at it, and then we'll move on to the next one. Moving on to the next question. A straight highway leads to the foot of a tower. So let's assume that this is the highway, and this highway leads to the foot of a tower. So this is the vertical tower. A man standing at the top of the tower. So if there is a man standing here, this is going to be his normal line of sight. So this is his normal line of sight. And this is the point A. The person is standing at point A. He observes a car at an angle of depression of 30 degrees. So he observes a car. The car is at the point C. He observes the car at an angle of depression of 30 degrees, which is approaching the foot of the tower with a uniform speed. Okay, so this is also moving with uniform speed. 6 seconds later, the angle of depression is found to be 60 degrees. So 6 seconds later, the car is at point D, and the angle of depression, that is this whole angle, is found to be 60 degrees. Find the time taken by the car to reach the foot of this tower from this point. So from the point D, we have to find how much time does it take for the car to reach the point B. So initially the car is at point C, then the car is at point D. It took 6 seconds for this change to happen. So it takes 6 seconds for this change to happen. And let us assume that it takes t seconds. It takes t seconds for the car to reach the point B. Now again, because the car is moving at uniform speed, I can definitely say that the speed of the car between the point C and D should be equal to the speed of the car between the point D and B, because it is moving with uniform speed. Now what is the speed of the car between point C and D? It is the distance CD divided by the time taken, which is 6. And that should be equal to, what is the speed of the car between points D and B? It is the length dB divided by the time t seconds. And therefore rearranging, I get t upon 6 is equal to dB upon dC. And now this is going to be my first equation. So somehow I have to find the ratio between the lengths dB and dC. So let us mark this length as x and this length as y and the height of the tower as h. Now because there are angles of depression, so I know that there is a 30-degree angle here. And according to the alternate interior angles, this angle should also therefore be 30 degrees. Similarly, there is an angle of depression of 60 degrees right over here, which means that this particular angle, angle ADB, should also be 60 degrees according to alternate interior angles. So now that the angles are known, I have to use two equations. So I will first say in triangle ADB. So in triangle ADB, let us see what equation I can build. I can say tan 60 degrees is equal to h upon y. Therefore, root 3 times y is equal to h. Let this be my second equation. And then I can take the complete triangle, that is I can take triangle ABC. So in triangle ABC, I can say tan 30 degree, tan 30 is equal to, the complete opposite side is h, divided by the adjacent side is x plus y. And therefore 1 by root 3 is equal to h upon x plus y. Cross multiplying I get x plus y is equal to h root 3. This is the third equation. Now I am not interested in h. I basically want a relation between x and y. Because if you notice, dB, the length dB is basically y and the length dc is equal to x. So somehow I need a relation y upon x, and now I am going to see how can I get that particular relation. So now what I can do is I can substitute h as root 3y in the third equation. So I will say substitute h equals root 3y in the third equation, and therefore x plus y is equal to h is root 3y times root 3, which means x plus y is equal to 3y, and therefore x is equal to 2y. So if x is equal to 2y, then I know that y upon x, so this implies y upon x is going to be half, and therefore replacing this value, this y upon x equal to half, let us consider this as the fourth equation. So I can now replace y upon x as 1 upon 2. Therefore t upon 6 becomes equal to 1 upon 2, which means that the time that it takes is 3 seconds. So the time taken for the remaining journey is therefore going to be 3 seconds, or from the initial point it took a total of 9 seconds to reach the tower. So this is how I can solve this particular question. Again, let me pause for a minute, but before that let me recap this question one more time. So this is the place where the observer is standing. This is the normal line of sight. The car is initially located at point C and the angle of depression is 30 degree. So according to alternate interior angles, we have converted the angle of depression into an angle of elevation. And 6 seconds later, the car reaches the point D. And now the angle of depression becomes 60 degrees, which means that angle ADB is also 60 degrees. Now we need to find y upon x. So I know that because the car is moving at uniform speed, the speed between CD and DB is the same, which brings me to the conclusion that T upon 6 is y upon x. I have assigned the letters y, x and h in this particular problem. So now I need to find y upon x. That is going to be the important thing to be found. So I found out two equations. Initially I took the triangle ADB. So using ADB, I first framed one equation, which was h equals root 3y. And then I took the triangle ABC, the whole triangle, and I substituted h as root 3y, and I got the relation y upon x is equal to half. So because y upon x is half, t upon 6 is half, which means the time taken is 3 seconds. This is how I found out the time taken to reach the foot of the tower from the point D. So pausing for a minute before taking up the next question. Moving on to the next question. A man standing on the deck of a ship which is 10 meters above the water level. So this is the water level. A man is standing on the deck of the ship which is 10 meters above the water level. So this particular point is the deck of the ship. This is 10 meters above the sea level, which is 10 meters above the sea level. So he observes, so the man standing on the deck of this ship observes the angle of elevation of top of a hill. So there is a hill here. He observes the angle of elevation of the top of the hill. So if the person is standing here, this is going to be his normal line of sight. So this is the normal line of sight. He observes the top of the hill to be at angle of elevation of 60 degrees. So this particular angle is 60. This is the top of the hill. So H is the top of the hill and L is the bottom of the hill. So this is the bottom of the hill. Let the point be P and let this be Q. And let this particular point be R. And the angle of depression of the base of the hill. So angle of depression of the base of the hill. Where is the base of the hill? The base of the hill is located here. So from the point P, if he is viewing the point L, then the angle of depression is found to be 30 degrees. So this particular angle is therefore 30 degrees, that is given to us. Now we have to find the height of the hill, that's HL. So we have to find the height of the hill, which is HL. And we also have to find the distance of the hill from the ship. So we have to find the length of HP, right? That is going to be the distance of the hill from the ship. This is actually going to be the distance of the top of the hill from the ship, but the distance of the hill from the ship is going to be the horizontal distance, which is going to be PR. So let me pause for a few seconds while you take a look at this particular diagram, just to note that if this is 10 meters, if PQ is 10 meters, then LR is also going to be 10 meters. So let me pause for a few seconds and then we shall solve this question. Okay, so let us solve this question now. Because I know the length of LR, I am going to take this triangle first to find the length of PR. So I can say in triangle PLR, tan 30 is going to be opposite side. The opposite side is 10 divided by PR. And therefore, 1 by root 3 is equal to 10 by PR. On cross multiplication, I get PR is equal to 10 root 3 meters. So this is 10 root 3 meters. And now because I know the horizontal distance PR, I can take up this particular triangle. I know that one angle is 60 degrees. So now I can find HR. So the right trigonometric ratio to use here again is going to be tan. So in triangle HPR, I can say tan 60 is going to be the unknown side, which is HR, divided by the side PR, and that is root 3 is equal to HR, that is not known, divided by PR is 10 root 3. So cross multiplying, HR is root 3 multiplied by 10 root 3, and that is going to be 30 meters. So the length HR is therefore going to be 30 meters. So the total height of the hill, is going to be 30 plus 10. So it is going to be 30 plus 10, which is 40 meters. And the distance of the ship from the hill, that is this horizontal distance, the distance of the ship from the hill is the horizontal distance, which is 10 root 3, and that is 10 into 1.732, that is 17.32 meters. So this is the height of the, this is the distance of the ship from the hill. If you want to find the distance of the top of the hill from the deck of the ship, it is going to be the hypotenuse PH, and that can of course be calculated very easily. Now that I know that this is 60 degrees, I want to find the hypotenuse. I know the opposite side, so I can simply use sine 60. So sine 60 is therefore going to be, opposite side is 30 upon hypotenuse is PH. So root 3 upon 2 is going to be 30 upon PH, which means PH is going to be 60 upon root 3, and that is 20 root 3, which is 34.64 meters. Therefore, if the distance of the ship from the hill is 17.32 meters, the distance of the top of the hill from the ship is going to be 34.64 meters. This is how I can solve this particular question. And we end our today's session here. Do take a look at the question, the diagram and the solution. And I hope that you understood all the questions that were solved in today's session. So pausing for a minute and concluding today's session here. ending today's session here.